Welcome back to Wickerson Studios. This playlist is actually taking off. It's single variable calculus, and I've gone back to a text I think I was looking at when I was 18 years old. Now that was a long time ago. And what I've done here is I've just plugged through it, and I'm excited to be getting into the coordinates and graphs now because it takes us beyond points, lines, curves, and actually into some of these geometries as they start as circles and ellipses, and we'll play off of some hyperbolas, and we'll work out of equations, and we'll find everything we can before we move into differentiation and integration. So what I have here is a little script, and I'll talk a bit about it first. Coordinates and graphs, the positions of all points on a plane can be measured with respect to a pair of perpendicular real lines. So there's our real line, and we'll call that one in the x direction. The x-axis, the horizontal, and we'll call the one in the vertical, the y-axis. 0 will denote the origin, and P will represent any point that is specified by an ordered pair of real numbers being x and y. And of course, we're going to get into grasshopper parametric script, and I'll show you why we're basically doing this. These are called coordinates of P. X is measures the displacement of P from 0 and y on the x-axis and y respectively on the y-axis. The Pythagorean theorem states the square root of x squared plus y squared will equal the absolute value of the distance from O to P. So we're basically finding out, and here's a more general formula of what we're doing. Now what I've done here is I went in and I scripted very basically this graph. That said, I then went on and I scripted in parametrically what the square root of x squared plus y squared would be. And my two variables are quite simple, and those are my x and y coordinates. So as I move this, you can see I can change that, and I can also play with my in the negative direction. Now I've set my range to -5 to +5 on the y and x axis, just so I don't get out of hand. And that's basically what the script does. So I'm going to build this from scratch. And I'm going to build it right off of the entire grid, and we'll start with nothing, and we'll start with building the x-axis and y-axis, and then we'll go on and we will generate the square root of x squared plus y squared. So let's give ourselves a little bit of playroom and start with the first part of that script. One thing I have here to begin with is this plane, and that's exactly where I'm going to start. So I'm going to take off all of this, and if I run into problems, I can always come back and look at it. So let's hit disable. And we have a default point that's here, probably from a past script somewhere. I can't tell you where. Maybe it was from the plane, but it doesn't seem to be defaulting. So let's just start with what we have. So jumping in here, let's do exactly what I did before. I will double click on my grasshopper window as soon as I have something big enough, and I'll type in the XY plane. And if yours is outrageous in scale, because scale still is important to all of this stuff, what I want you to do is go into displays and check out your preview plane size, and I'm working at 5 because those are going to be how far I go in the x and y direction, positive and negative. So I just changed my plane view size to 5. So that'll be 1, 2, 3, 4, 1, 2, 3, 4 coming up, and that'll make pretty good sense with what I'm doing. I'm going to do everything the same as what I've been doing like crazy, which is building points. And that's really how I come about sculpting in Rhino, is I think about generating points from certain things. And of course, I'm going to be producing 2 points. I'm going to be throwing those through a range, which I've shown you before. And the fastest way is to know you need one, so you can just double click it. One thing I haven't shown is just the Control-Alt, and then holding down the left mouse button will show you exactly where these items are in the ribbon tool. And that's pretty good because that works for plugins as well. So that's pretty good. Plane should come up. There we go. So the range I'm going to put in the x direction, and I'm going to put it in the y direction. And I am going to create a domain because I don't want to get lazy. And the domain will be with a negative value. Actually, I think I'll set the domain by double-clicking a slider and go from -5 ... to 5.00, which will give me 2 decimal places. And I'll move it from negative over into the positive, and I can change this if it ends up becoming an issue. So there it is. Those are the numbers I'm actually going to use, and I actually am going to bring that down to about 3. I don't need that so big. The domain in those ranges, I think that'll be enough to articulate. I don't need to go to 0, 5. I think I can actually come back up to 0. I can have it snap if I want, and I'm not sure why I did that from negative domain to start domain. But I think what I'll end up doing is just typing in a 0 and make that a simpler script, so I don't have to worry about it. And that's, well, I better still use it actually. instead of going in 0, we're going to want it right about in the middle. So I'll double click on edit, and I'll bring that up to 0, wherever that is. I might have to double click on it and type in 0. And another little trick that I might show you is, I think that's going to be fine. In this direction, the range, I pushed it in the Y and in the X, and I'm going to give it 10 steps just for a little bit of finesse if I end up wanting to do any trigonometry on here, which could be kind of fun. So I'm looking at my points. I'm saying, what is going wrong? I've got my domain end, my domain start, and it should be fine. I'm wondering why my lines aren't oh, I know exactly why I'm such a fool. Here's what we're going to do. We're just going to play with those lines from 0. I'm not going to confuse it by going ahead or behind. And if you do want to use edit snapping, I forgot that I did that. Let's put in 0. And so we can have that snap to 0 when we want it. So there we go. And that's actually only the number you need. I guess I did a little overwork. What I'm going to do with this, because these are 2 lists, is I'm going to grab a list item. And what's nice about the list item, I've been doing this recently since I learned it, even though I was like 3 years late. Zoom in here and add the -1, which will find you the last digit in the list. That's just something that's very interesting. Pop in your list, and now you're able to grab the start and stop. And I'm going to produce a 2-point vector from that section. So 2-point vector here, and I'm going to produce a 2-point vector here. And of course, I'm going to want from up here, I will want to come from the last point to the first point, which will give me a nice vector here, which I can't quite see yet, but I'm going to show you because vectors aren't visible. And this one, I'm going to go from the first point in the list to the last point in the list. Now I have 2 vectors here, but I want to visualize them. So I'm going to create a point that will default to 0, 0, 0. That's nice and easy. And then I will create under display, or nearly done, 4 vectors to look at. So that might be interesting why I did that. I'm going to try and show why I did it. Nice thing to do, space that out, and then do this, center them, and there you go. You get a nice organized list. The anchor points of every one is going to be from center, and all I'm going to do is take that simple vector. There's so many ways to come at this. Take that vector and push it in this direction. There's my vector off in the X direction, positive, and there's my Y off in the Y direction. Just hit the wrong one in the Y direction, positive. There it is. I can show you by hitting select. And then let's take our negative, and as long as you start to organize and script things this way and think about things this way, you should be able to, I need my vector, not my point. There we go, off in that direction. And we'll do another negative over here from this vector in this direction. Pop that in there. Now we've got all 4 vectors coming up as we select them. And there it is. And we can push that beyond that grid if we want, just by making this a little larger. We'll just move it out just slightly, and we'll shrink it down, and we'll have our points. Now, what I'm also going to do is take off everything, and I don't see anything but the vectors. Except I do want to see that plane, so I'm not going to take that off. And let's just hit visuals, off, and there we go. Nice little highlight. We've got something to start with, and there's our simple model. Nice thing to do is get in the practice of Scribble tool. Double click on it. Let's call this X axis and Y axis. So it's labeled right. We'll make that big so we can see it from a distance because our script is getting pretty huge. We will take it all and we will group it. Oops. Let's go back on that. Let's take it all, and it's got a little delay here. Holy cow, what is going on? Okay. I guess I've just got too much going on in the script. Preview off. Or maybe it's getting late. I've done doing too many of these. Let's group it and let's organize that. And we'll probably get rid of it in the end, but move it by the blue. And there's our script to start, which gives us our chart, and we'll come back and use that. So we can go plus minus in what direction we can aim it. The domain start can just be at 0. You can cut this down and you can clean it up as you get better at Grasshopper. It's not all necessary to have all this stuff, and in time you want to push this all into a Python node or into a plugin so you can produce these very fast by just imagine going up here and just saying, okay, I need a grid, so I'll just build something on the ribbon tool that are my own kind of plugins. What I do is I write an awful lot of Python nodes, so I've got a lot of basic curves, data functions, geometries, and actually you end up scripting that in Python, or you can choose C# if you like, or I think you can use VB script. over here, if we take a look at scripts, you can end up getting a little deeper into what you want to do. Yeah, VBScript, which I don't know much about. Learned a little bit about it in Rhino. Okay, so those are the points. Now let's build the more elaborate script. And I want to get rid of that one, and I want this one to be huge. As I may look at it, and this one isn't too bad. I'm going to tuck that one away because I don't need it. And now what I'll end up doing is superimposing something on top of there. So you're thinking of like functions that would go into something like a class that could go in the modules. You could make this into a plugin, but right now I'm just working through my old book, Single Variable Calculus, because I enjoy it so much. If you told me I'd be doing this after 30 years of making sculpture, I never would have believed you, but this is where I left math off a long time ago, and I find it interesting to return. We're going to be doing a lot of text tags now, and I just want to show you what's going on. So let's go in here and let's start with finding a point, and I'm going to have a point that can go anywhere between -5 ... and 5.00, and that will be x, and I can also generate that as y. Let's just sporadically say, okay, let's have a positive in the y and a positive in the x, just to start in the right top quadrant, and let's produce basically a point from that. So let's go into here and let's grab our point. My wires could get a little messy, but there is our point over in the x direction. And what we can do is also put that over in the y direction. So there we've got our point of where it's going to go. And we're basically going to measure the distance between 0 and that point. And of course, we're going to need 0 to do that. So there's our point 0 coming up again. And we want to know the distance between here and here. And that's what our equation is going to figure out. We don't need to see these ones right now. We'll take preview off, and we will actually generate 2 more points. So I'm going to grab another point here, and we'll copy that one because it's not preview off. And I'm going to, before I do it, I'm going to take that point that I had, and I'm going to deconstruct it, which seems strange because I just built it. But there's a couple of things I want about that. And I just want the x-coordinate, but I want to see where it came from. I could draw it from back here, and I could draw it from here, but I don't mind doing this. Grab the y component, and now so you're thinking through. So you have these 2 points, you have this point, and you have these 2 points that you started with. And I literally only want to see the lines. So I'm going to go in and grab some lines. I'm going to grab 1, 2, 3. Space them, grab them all, center them, and space them apart. And your first line, you're going to go from 0, origin, over to the point that was over here, and you've now drawn, but you could find the distance by hovering over it and tell you exactly what it is, because Grasshopper is so great. But I want you to go deep into this and what's happening, because when you go deeper, you can actually script and code all of this. I'm also going to go from 0 and go to this point, and that's going to generate that one. And I'm going to go from 0 and go up to the y point. And that's it. I've got my 3 lines, and I'm still going to keep on these 2 bits, and I might keep my origin on, and I might, my P on, and I might take this one off. So that will allow us to see pretty much everything as that system. The only one I really want is the hypotenuse. I'm going to want to go in and find the midpoint of that because I want to put something on there. And the other things that are going to happen is I wanted to show you another way to generate distance, because the distance has been generated by this line and we can measure it. But I wanted to show you basically what's happening through an equation, which would help. Now you could always grab the distance node, because Grasshopper wants you to have all these plugins and have things to do. So you could grab from 0, you can grab it either way. You can grab this one over to the point A and this one over here, and it'll give you an absolute distance, and you'll end up getting that value that this line is giving you in the total. And just to see it, let's put it over here. And there it is. But there's other ways to come at that, and I think the more interesting way to come at it and to have a script would be to go in and use a little bit of math. So I want to use that expression node. I want to go in here, and I want to right-click and take that down to variable x, and I want to take this one down to variable y. And you don't have to put these in as integers or floats, because this node does that for you. You don't have to write anything fancy, but you're going to grab your x and y, and I'm going to grab my x value. One thing I should do to clean it up and make a better script is I should go in here and say that is going to be the attribute p at x. So I could go down here, but I think it's simpler and it's implied if I just put this in as x and this is in y. So you reuse the data quite a bit, and then what I want to do is I want to go in here and use this equation going up here and find out what the square root is. Square root is capital SQRT, and you have to write it with parentheses what x is. Well, we have a formula here. So let's type it in, SQRT, x caret squared plus y caret squared. And that's going to give us an equation that's going to actually work. And that gives us an output. And of course, you know what that output's going to be. We'll take this panel over here. And as we plug this one in, you'll see it didn't change at all. Now, there could be some rounding problems and other things that happen and integers moving in the floats and stuff like that. But there's some values. And what I want to do is just put this into a couple of things and start labeling this structure and put some interesting things in. And strangely enough, I'm going to do 3D, which I've been doing quite a bit now, text tags. And I'm going to make 6 of them. I'm going to make 1, 2, 3, 4, 5. And I'm going to space that one way down here. And I'm going to grab them all and do the same thing I do, just get them all organized. And I'm going to take the location of my midpoint, because that's the information I want over here. My script, I'm going to hard code 0.12 because I like that size. And that's going to be the size of nearly everything. Size, 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 size. So whenever I get repetitive, I know my code could be made. Theory of parsimony, Occam's razor, that's all the stuff you want to think about. The text that I'm going to put in there is actually going to be a text fragment. I'm actually going to use concatenates. Since I've been making labels and diagrams so often, sets, let's go into here and let's grab concatenate. And I actually want to bring that data in, which has been generated here, and I want to throw in a little fragment text of underscore, 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 and have that go in first. And then as I bring that in as text, you'll see that that gets placed right here. Really nice spot for where it is. And that's not the only text I'm going to bring in there, but right now that's the one to start. And that will give me a little indication. What's nice is as I start to run through the script, you'll see that that one has to behave and change, and that's basically all the script needs. But I want to label my chart a little more. Now, mind you, if you're good at Matplotlib and all these other Python plugins and everything, you don't need to go into this, but this is for those that take a real interest in this. The other thing I want to do is locate at the midpoint another thing that's going on. I'm going to position this one, I think, as, where am I going to position this one? We'll see after I get it typed in, but I want to put in a little bit of text, and I'm going to actually put in spacing a bit. D for distance is equal to the square root of x caret 2 plus y squared, and we want to make it look nice, and I'll end up doing some better scripting in a bit. Enter that. Throw that into the text, and there we go. And the problem with that is I'll probably want to justify that. Let me go in here and just drop it down a bar and go of 1, 2, 3, 4. Let's see where that one goes. That one goes in pretty close to where I want it. So let's just stretch out that text and have a little bit of fun with the script. And of course, this is not, speedy machine learning or anything, or artificial intelligence figuring this out. This is old man Wickerson doing this to be very playful in what's happening. And there we go. I've got my data in here. It's been marked. It's the formula, but it's also the actual numbers of what it is. And the last things I want to do is I just want to indicate on y, on I believe point y, which was this one. I just want to bring that one over and have a location here. And we'll just do a quick little y, space. That should be fine to pop in text here. Pop it into the correct location text. That's going to put y there. And I'm also going to do y. Let me do justification right bottom. And when I go in here, I'm going to put on some spaces here that'll push it over. There you go. So you got to do a little fudging like you're working on a screen. And then the other one, I'm going to grab X for the next one. Looks like we've got a dog that's going crazy, which is fine. I'm going to pop in an X here. But this X, I'm actually going to put it down one, and X here, and that should be fine in positioning, kind of placing it and thinking sculpturally on what it is. And we should have a X value here as a point. You could find them from the ends of the lines as well. Wouldn't be too hard. And there's X, which is in a good enough location. don't think I need the fifth one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why did I have 6? I don't think I needed them. Maybe I neglected to do one. Oh, there was one other point that I didn't do, and let's just do it here. Let's do capital O and get that one in. Oh, let's do parentheses and shift 0. And that should put us in a text at the center, which is this one, right dead center. But we want a justification top right. That should push that one down. And we could always go in here and fudge it down a line and space it over a few. And there we go. We move O just a bit out of the way. And then the last one is, what was that? Oh, the formula itself. I'm going to go in and type in capital P is equal to X at Y. And that's going to be a little bit of text that I will maybe space over 1, 2, 3, 4, hit enter, and that will be my text that will go in at our point where is it? Should be this one up here. Well, it is coming through. Is it this one? Why am I thinking midpoint? There's the line. That's the end point there. Sometimes I lose my mind. There we go. P. So now you have a nice little script. You've planned it all. You've written it out. You've actually learned to sculpt, and that's what this is all about. We're going to group that. We're going to go into here, and I like this script better than the one I did on the last one. So I'm actually going to play around with changing that, moving it up and down, go all the way up beyond where it needs to go to 5. I can take it here. I can drop it negative. I can drop this one down below the negative, and you see it all changes. Of course, it falls a little bit in its way, but it's a pretty powerful tool. And you've scripted it yourself, and you've thought about it yourself, so you start to feel pretty confident. It's not too hard to start thinking about moving into Python or into Grasshopper. So what I'm going to do is I'm happy with what I've changed. The only thing is this one, if I put this one on, I just want to double check for a second on enabling. You'll see that all I took out was these two. Everything's matched. I think I can take this one and we'll take that, remove it from group. We'll slide it over here. Take this one out because we don't need it. And we will just put this one over here and zoom on in and add this to add to group. And that should be it. And I can get rid of this one, which was my older script, which I'm okay with. And this one as well. I think I will delete all that and slide this one in. So just taking a chance on showing that I trust my new script quite a bit. But I like it. I can go back in here. I can zoom into the factors that change it, X and Y. I like that these ones are actually marked. You get more and more finesse as you zoom in on here, so you can control them. And you have your outcomes. The only thing I like here is selecting some of the visuals. And of course, you have to have those selected for them to work. And we'll just pull this one out again, and we've got a nice little chart with everything we need to go parametrically make our own grid. Now imagine where we're going to take this. We're going to take this into circles, ellipses, geometries, and when we start to really bring it into multi-dimensions, we're going to start hauling this up, and we're going to fully understand what we're supposed to be doing in Rhino on a very computational and parametric level. Thanks again for watching.